Okay, gentlemen, so today we're going to look at the Calculator Bootcamp number 5. This is the last one. This is on significance testing using the calculator. So what we're going to do here is we're going to run through 4 problems that are shown on the screen. I'm going to use the 84 plus first for all 4 of them, and then I'm going to do all 4 of them on the NSPIRE. So if you don't have the 84, but you do have the NSPIRE, you can skip to about halfway through the video. If, on the other hand, you have the 84 but not the NSPIRE, you could watch the first part and then stop. Alright, so let's look at this first problem. A farmer claims that his very large collection of cows has an average weight of 1,700 pounds. However, you randomly sampled 35 cows and notice that their weight is 1,650 pounds. With a standard deviation of 49 pounds. Does this sample give you reason to doubt the claim? So the claim here is that the large collection of cows has an average weight of 1,700, and we are getting a sample that's less than that. We have our sample data, so what we're actually going to be doing here is a t-test, because we are looking at weight, which is a mean, not a proportion. So what we're going to do on the 84 is go into stat, we're going to go over to tests, and we're going to go to a z-test, or sorry, a t-test, excuse me. We have this t-test, we actually have the stats here. So our assumed mean, the claim is that the cows weigh an average of 1,700. Our x bar was, let's see, 1,650, that was the mean of the sample, and our standard deviation of the sample was 49. The n here was 35 cows. We don't have a direction necessarily, so we're going to go with not equal to the claim, and we're going to first draw this. Okay, looks like we have a very unusual sample here. Let's see, I think I can just clear that. We actually have to go back into the test window to get that back. But we should just at this point be able to go back down. And what we're going to do is calculate this again and look at that. So our t statistic is -6, which is very, very big and negative. Our p is the 10th and -7th. That's going to be far below our usual alpha level of 0.05, and it'll print back out those summary statistics for us. So this would be, yes, this sample would give us reason to doubt the claim. This is a significant finding since the p-value is well below any relevant alpha level. Let's look now at number 2. A journalist claims that 75% of all kangaroos have big feet. However, you draw a random sample of 1,500 kangaroos and note that only 74% of them have big feet. Does this sample give you reason to doubt the journalist's claim? Okay, this is a proportion question, so we are using a z-test. And in this case, we'd probably like to just use a 1 proportion z-test. Okay, so our assumed probability is 0.75. The number of successes, well, let's see, our sample size is 1,500, 74% of those, so 0.74 times 1,500 turned out to have big feet. We are just testing whether the proportion is different from the claim. The first thing I want to do is actually draw this. Okay, so that looks like that actually could be pretty likely. We are seeing a z-score of only -0.89, which is just not that unusual. Notice that, 74% is not all that different from 75%. And our p-value is 0.371, which is going to be well above the alpha level, so this is not going to be significant. Let's just see what it looks like if we did the calculate option on that test. We go down here, and it would print out the z-score for you, which is -0.89. It would print out the p value here, which is 0.37. Again, that's well above the alpha level, so this is going to be non-significant. Okay, number 3. Mr. Moon has drawn a random sample of 10 students from last year and this year's classes to see if self-distancing has actually increased student enjoyment of his class, since they can now do it from their couch. 5 of last year's students rate his class positively, while 7 of this year's students rate his class positively. Does this support Mr. Moon's claim that class enjoyment has increased? Well, I'm going to ignore some possible confounding factors, like the fact that I've been teaching for another year, so hopefully my class is just better. But we're going to treat this as if it's a straight up experiment here, and I want you guys to think about what condition is violated here. Well, think about sample size, and I think that'll help you out. So I'm going to show you how to do the test here. We are actually again going to go to test. This is another proportion case because I'm looking for the proportion of students that like the class. In this case we have two proportions. So I believe we are using a two proportion z-test. Yep. So our x1 had, this was 5 successes out of 10 students from last year and 7 successes out of 10 students from this year. First thing I'd like to do is actually draw this. Oh, actually, I'm sorry. We need to change our thing here. So our P1 is last year's enjoyment. Our P2 is this year's enjoyment. Mr. Moon's claim, or my claim, is that class enjoyment has increased, meaning P2 should be bigger than P1. So we're actually going to choose this alternate hypothesis. Let's draw that just to see what it looks like. Okay, so it looks like here the z-score is negative 0.91, not all that unusual, and the p-value is 0.18. Notice that this is a one-sided test, which should have made it easier for us to reject the null hypothesis, but we still weren't able to do it because that p-value is just too high. Okay. We're looking at the last problem now. This is the one with the random sample of 31 of Mr. Moon's friends. For the sake of this experiment, assume that this is a large group. You can imagine what the number of friends I have on Steam would have to be. I'm not sure it's quite that, but we'll assume it is for this. And we're going to say that they averaged 5 hours for 2 weeks of gameplay on Steam before the coronavirus outbreak. In the past 2 weeks, Mr. Moon notes that a different random sample of 32 of his friends averaged 100 hours per 2 weeks of gameplay on Steam. So we're going to look at whether this is a significant difference. Now, hours, we got to use a means analysis for. So we're going to not go into the mode settings. Gosh, we're going to go over to tests and down to a 2-sample t-test. Because we're doing mean work, we're doing a t-test. So let's go there. We have our summary stats. So x bar 1, oh, I didn't give you guys standard deviations. Well, let's assume for the first one that we have 5 hours a week, and I'll add this to the worksheet afterwards, but we'll go with the standard deviation of 1 hour, and that was with a sample of 31. In our second group, we have 100 hours, and this one was more variable, so it was actually 25 hours as our standard deviation, and this was a sample of 32. We're going to see if those are different. I'm not going to pool it. We are going to draw it. So when we sketch that, yeah, that's significant. Okay, so our t is negative 21.4. That's massive. The p that we get out of that is so close to 0 that we basically would call it that. So we're going to say that p is less than 0.05. We're going to reject the null hypothesis. And we're going to see that definitely more people are playing more video games in quarantine. Okay, so as quickly as I can, I'm going to repeat those steps on the NSPIRE. So let's start off with the first question here. A farmer claims that his very large collection of cows has an average weight of 1,700 pounds. However, you take a random sample of 35 cows, and you note that their weight is only 1,650 pounds, with a standard deviation of 49 pounds. By the way, I had to do some cattle research to write this question. 1,650 pounds is a lot closer to the average cow than 1,700 is. So I'm going to assume going into this that we can doubt the claim, but let's see if that holds up. So what we want to do here is actually a t-test with one sample. So we're going to go into stat tests, and we're going to go to, we can use just a simple t-test. We're not going to input data, we are going to input stats. So our claimed average, by the way, the reason I know that this is a t-test and not a z-test is that we're talking about weight, which is a means thing. It's not a proportions thing. you can't really talk about weight as a proportion. That doesn't make so much sense unless you're talking about the percentage of people that are a certain weight, or so on and so forth. But in this case, we're dealing with a mean weight of 1,700. We have sampled 35 cows. Their mean weight is 1,650 with an average standard deviation of 49. And our N here is 35. We randomly sampled 35 cows. We weren't given a direction here, so we're just going to say not equal to as our alternative hypothesis. Run that number, and here's what we get. Okay, the t-value is quite large in the negative direction, so we get negative 6.03. That's going to give us a very, very small p-value. So we are going to doubt this claim because the p-value is so far below the alpha level. Okay, in number 2, a journalist claims that 75% of all kangaroos have big feet. However, we draw a random sample of 1,500 kangaroos and note that only 74% of them have big feet. We're asked whether this sample gives us reason to doubt the journalist's claim. Well, I see proportions, so this is a z-test. Okay, we're going again to statistics, stat tests. This time we're going to go to a one-prop z-test. Okay, now the assumed proportion is 0.74. Sorry, 0.75. Confusing myself. Out of 1,500 kangaroos, 74% were successes. So I'm just going to use that expression to model that right in the calculator. And the number of kangaroos in my giant sample was 1,500. By the way, that's absurd. That's a huge number of kangaroos to survey for this study. We were not given a direction, so I'm just going to say again that the proportion is not equal to the claimed proportion, and we'll roll that through. Okay, in this case, the z-score is not all that big. Negative 0.89. It's unusual, sure, but not that unusual. Our p-value comes out to 0.37. That just doesn't give us a small enough p-value to doubt this claim. Remember, if the p-value is above 0.05, we tend not to reject. If the p-value is below 0.05, we tend to reject. So let's look now at number 3. Here, Mr. Moon is drawing a random sample of 10 students from last year's crew and this year's crew. And we're going to see if student enjoyment of my class has increased this year now that students can do it from their couch. So last year, 5 out of 10 rated it positively. This year, 7 out of 10 rated it positively. That seems like an increase, but let's see if it's significant. And we want to see if this has actually increased enjoyment. So we're going to need to look carefully at our alternative hypothesis. We're going to again go into menu, statistics, stat tests, but this time we're going to go, statistics, stat tests. This time we're going to go to a two-sample z-test, and two-proportion z-test. So we're looking now at the two samples. So in the first sample from last year, we had 5 successes out of 10 students. This year, we had 7 successes out of 10 students, and our alternative hypothesis is that actually P2 is going to be bigger than P1, so P1 should be less than P2. Note that the question asks, does it support my claim that class enjoyment has increased, not class enjoyment has changed? So let's see what this looks like. Well, Z is negative 0.91. That gives us a p-value of 0.18. That's not lower than 0.05, so it's probably not significant. It doesn't give us statistically significant evidence that class enjoyment has increased. By the way, look at this problem closely and see if you can spot the condition that's violated here. I'll give you a hint, you want to focus on sample size, but it's not the fact that n is less than 30. It's actually something a little different. Okay, let's look down at number 4. This is our last problem here. So a random sample of 31 of my STEAM friends averaged 5 hours for the 2-week thing that STEAM measures before the coronavirus outbreak. In the past 2 weeks, however, I noticed that a different random sample of 32 friends averaged 100 hours. And the standard deviations there were 1 hour for the first sample and 25 hours for the second sample. What we have to do here is a 2-sample t-test. Notice that number of hours has to be a means case. It's not going to be a proportions thing. We are going here off stats. In our first sample, the average was 5, standard deviation was 1, and I surveyed 31 friends. In the second sample, the average was 100, the standard deviation was 25, and the number of friends was 32. I'm just looking to see if there's a difference, and I'm not going to pool here. As you can see, the difference is massive. That T score there is negative 21.4, and the p-value is so small that we can essentially call it 0 at this point. So that's well below 0.05, even with those degrees of freedom. And that says that, yes, this gives us evidence that this is a significant difference, which makes sense as the coronavirus has forced a lot of people to quarantine indoors, and that has meant more video gameplay. Hope you guys enjoyed this video. Hope it helped you out to use the calculator for a lot of these tasks on the AP test.